It's the sine of an acute angle. It's the ratio of the opposite side to the length of the hypotenuse. And remember, when we see SINA, what we're going to start saying out loud in our minds, and when we read it out on paper, is the sine of angle A. Not sin, sine, the sine of angle A. I've used my highlight strategy where the hypotenuse is highlighted green, the opposite side and the adjacent side are yellow and orange respectively. And I've put this symbol, it's the Greek letter theta, and it's going to become universally known as our angle symbol for trigonometry. Because sometimes that angle can change, and so we have to have a variable or some sort of letter or notation that lets us know that that angle has yet to be figured out. So when we talk about angles, theta is going to go in that location. Now, to complete the ratio that represents the sine of angle A, the sine of A will be the length of the opposite side of angle A, and that's this one in yellow, BC. The length of the hypotenuse, which is green, which is across from the 90-degree angle, the length of the hypotenuse is going to be our bottom part of the ratio, AB. So now we're able to talk about sine ratios as this relationship between opposite to the hypotenuse, or BC to AB. Cosecant is the other trig ratio, and cosecant takes the sine ratio and flips it. We could say it's reciprocal. So cosecant is going to be the ratio of the hypotenuse to the opposite side. And we would write it as CSCA, but we would read it out loud as the cosecant of angle A. Right here, the cosecant of angle A. So to complete the ratio that represents the cosecant of angle A, it's the flip of what we observed for sine. Get out of here, low battery warning. So the length of the hypotenuse is AB, and the length of the side opposite angle A is BC. But both of these two fractions, they're the same fraction, it's just which one is going to be in the numerator and which side is going to be in the denominator respectively. We have a picture from the getting started where we looked at sine ratios, although we didn't call them sine ratios in the beginning, but now we officially can. So in the getting started, we said that triangle 1 has a 21-degree angle, and so therefore the sine of 21 degrees is going to be the opposite side divided by the hypotenuse. So I can write that ratio as 19.3 divided by 54. A reminder, in the previous video, previous page, I put millimeters because the measurements on that triangle were in millimeters, and we should put them as well. But after you write those units of measurement down, they cancel out. In the next one, triangle 2, the sine of 35 degrees is opposite divided by hypotenuse. So the opposite side is 34.4, and the hypotenuse is 60. 34.4 divided by 60. In the last triangle, the sine of 39 degrees, it's opposite divided by hypotenuse, so 39 divided by 62. Now, the rest of this question says, round your answers to the nearest hundredth. We already did that on page 564, so go back and look at those ratios and write those decimal values here. I'm not going to do that now because I already did and you took good notes on them, but you should write them down here. What we can observe, though, is the same thing in question 3 is happening here in question 4. As the angle measure increases, the sine of the angle, so that would be like written like this, the sine of the angle, or this sine of the angle. In fact, these angles are going bigger and bigger and bigger. So as the angle increases, the sine of the angle will also increase. That's been page 565. Thank you for watching. Page 556 is next. Understand that sine ratios are just knowing the opposite and hypotenuse sides of a right triangle. See you in the next episode. Thanks, bye.